Today I'm going to show you how to put together a base project for the Arty and Artix-7 FPGA board from Digilent. So before you start this project, you're going to have to install the board preset or the board files for the Arty. You'll find those on the Digilent website, and I'll leave a link at the bottom of the video. So all I've done so far is to create a project, select the Arty preset, and that's Vivado has created my project. Now I go create block design. So I'm going to make this easy on myself, and I'm going to rely on the peripheral configurations that come out of the board file. So if you go into the board tab, you see them here. So I'll start by putting the system clock into the design. That gives me a clocking wizard, and that's going to be clocked by the onboard 100 megahertz oscillator. Now I need to configure the clock wizard to give me 3 clocks that I need for my design. The first 2 clocks are going to be for the DDR or for the MIG, the MIG, and the last one's going to be for the Ethernet PHY. So I'm setting them here. The first one to be 166 megahertz, the second one to be 200 megahertz, and the third one to be 25 megahertz. Like I said, that's for the Ethernet PHY. And the other thing I want to set is I want to set the reset to be an active low reset, because my system reset signal that comes in is active low. So now I'm going to externalize the clock 3 out right away. That one's going to go straight through to clock the Ethernet PHY that's on the board. It's a 25 megahertz clock. So I'll rename it Ethernet ref clock. And we're going to add a constraint in for that, a lock constraint for that later on. So now I'm going to use the connection automation to hook up my system reset to my clock wizard. Now I'm going to drag in the DDR3, which is a MIG. So that gets set up automatically and connected to the DDR. Now I need to hook up my clocks. The 166 megs goes to the sys clock, and the 200 megs goes to the clock ref. Now it's automatically been hooked up to the sys reset signal, but that's not right. I want to use the system reset from the board preset. So I delete that reset port and I connect it up to the real reset port that was created earlier. So now I'm going to add my microblaze to the design, and I'm going to use the block automation to configure it. Now I'm going to use a pretty general configuration here. I'm going to do it thinking that I might use this to run Linux later on. So I'm going to give it enough memory. I'm going to enable the interrupt controller, and as a clock connection I'm going to use the MIG's UI clock, which is 83 megahertz. So that my whole design now is going to rely on this 83 megahertz coming out of the MIG IP. Now I'm going to use the connection automation to hook up the microblaze to the MIG. I just check through each of those settings to make sure that the connection automation feature is going to do the right thing. Now I can start dragging in my peripherals. So I'll drag in Ethernet. Now that's going to be an Ethernet Lite IP because it's only a 100 megabit per second Ethernet PHY. It's not a gigabit Ethernet PHY. I drag in the quad SPI flash. Now that's also more for Linux. I'll drag in the LEDs. So the LEDs are basically GPIO. So it's a GPIO IP that's going to be hooked up to the external LEDs. Now I'll hook the push buttons in. Notice that it takes up the same, so it will just create another port on the AXA GPIO IP to connect those push buttons. And now when I hook up the other LEDs, the RGB LEDs and the other switches, it will create another AXI GPIO for that, because a GPIO IP can only have 2 ports on it. Now I'm going to drag the USB UART in there. Obviously we need a UART to get a console output for this thing, a debug output. Now the last thing I'm going to add is an AXI timer. The reason I need a timer is because I'm going to run the lightweight IP Echo server application on this, and that needs a timer. Also Linux, if you want to run Linux, you'll need a timer as well. So now I'm running the connection automation to hook up all the slave AXI interfaces on all these IPs through to the micro blaze, so the micro blaze can control them all. Now I just set the AXI quad speed clock to be the right one, which is the 83 megahertz coming out of the MIG, the MIG IP. So now the automation feature has connected up all of those peripherals through an AXI interconnect through to the microblaze. Now here I'm going to hook up my interrupts. So this is the concat through which all my interrupts go, in order to then go through to the microblaze AXI interrupt controller. So now I'm just hooking up the interrupts for each of those IPs that have an interrupt, which are the Ethernet, AXI Ethernet Lite, the AXI Quad SPI, the AXI UART Lite, and the last thing is going to be the AXI timer. So just check over the design at the end. Now that I'm happy with the design, the block design, I just save it. And the next thing is I create a HDL wrapper for the block design, and I'll let Vivado manage it. So now the last thing that I want to do is hook up this Ethernet ref clock. You can see from the schematics there's a crystal on the Arty, but it isn't loaded. So we have to actually drive this 25 megahertz clock from our FPGA. So what I'm doing here is I'm creating a constraints file for my design, and into that new constraints file I'm going to add a couple of constraints. One is a lock constraint to say where to what pin that Ethernet ref clock is going to go to, and the other one is the IO standard. So that's a 3.3 volt standard signal there. So now that's done, so I can click on generate bitstream and we're done.